Hello, I am Muhammad Jahirul Islam. I am from Bangladesh. Currently, I am working as a research assistant in SR Lab under supervision of Professor J. Young Park. Now, I am fourth semester student in Kangal University. My research interest is in energy harvesting using triboelectric nanogenerator technology for cell power application. I am review of MMIC technology. Discuss definition of MMIC. The term radio frequency represents a range of frequencies in electromagnetic spectrum above the audio range and below those of infrared light from 10 kHz to 300 GHz. All wireless transmission uses RF radio frequency including AM and FM radio, TV, satellite communication, portable phones, cellular phones, and wireless network. RF signal can be focused in one direction or they can transmit in all direction also. In case of MMIC is an integrated circuit used in frequency from 1 GHz to over 100 GHz. That's wavelength from 3 centimeter to 1 millimeter. This one is application in mobile phones, and this MMIC also known as monolithic microwave or millimeter wave IC. MMIC combines of active and passive devices like transistor, inductor, capacitor on the same chip and are widely used as a amplifiers and filter in telecommunication. We will discuss about the definition of MMIC. First part here, uh, which frequency range we use, which application. What is the frequency? Frequency means cycles per second. Per second, how much oscillation is occurs. That means a frequency. In case of 3 to 30 kilohertz, its abbreviation VLF. Its division is micromillimeter wave, and application in marine. From 30 to 300 kilohertz, its abbreviation is LF, long frequency. That's division in kilometer wave. Application is wireless station. In 300 to 3000 kilohertz, it's called MF. Its division is hectometer wave, used in international HF communication. Had different type of frequency range. In case of 3 to 30 gigahertz, its abbreviation HF. Its division is centimeter range wavelength. It's mainly used in application is satellite communication. For space communication is EHF, millimeter range wavelength. That's frequency range is 30 to 300 gigahertz. For electric wave and astronomy, the decimeter wave range wavelength, that's frequency range 300 to 3000 gigahertz. This on frequency range and commercial uses of frequency. For commercial uses of frequency range for our cellular application, the transmit frequency range 824 to 849 megahertz and receiver frequency range 869 to 894 megahertz. For GSM, global system for mobile communication, mainly the slot divide in from transmit range is 880 to 915 megahertz and receiver frequency range it's 925 to 960 megahertz. In case of personal communication system, PCS is transmit range frequency is 1070. For personal communication system, that's called PCS, the transmit frequency is 1750 to 780 megahertz, and for in case of receiver, 100 for receiver case, 1840 to 1870 megahertz. For here also here application, wide local area network and direct broadcast satellite have different frequency ranges. Here, now comparison between MMIC and hybrid IC. Now, first of all, what is hybrid MMIC and what is MMIC? Hybrid MMIC is a IC. Their active device and some of passive elements or discrete components mounted on dielectric slab or is on substrate to guide electromagnetic energy to various circuit components. On the other hand, MMIC technology, in which the active and passive components are formed on same substrate and eliminated many of problems associated with hybrid integrated circuit. Comparison MMIC and hybrid MIC. The merits of MMIC and hybrid MIC. For MMIC, it's no returning engineering, that its cost is very high. Size and weight are very small. Mass production cost is very low. Very good design flexibility, relatively good broadband performance, high level of integration is possible, and reproducibility and reliability are excellent. In case of hybrid MIC, non-returning engineering cost is very low, size and weight are very large, mass production is very high, good design flexibility, limitation of broadband performance, high level of integration is impossible, reproducibility and reliability are just fair to good with good uh, repairability. Here we can understand the MMIC is more good than hybrid MIC from this table. Now, advantages and disadvantages of IC and applications. First of all, here I discuss the advantages and disadvantages of MMIC. Then I will go hybrid MIC. MMIC advantage mainly mass production cost is low but requires significant investment to develop. Disadvantage, state of art performance is not possible. Complex MMIC have poor yield due to the multi-capacitive effect. Here the hybrid MIC, the lot of advantages like cost is very low for simple circuit and requires comparatively small investment to develop. Size can be smaller due to compact multi-layer substrate, and time required for layout, construction and test is comparatively small. Disadvantage is does not have good reproducibility and reliability due to the hand tuning and bonding of the devices or components together. And now mainly application where we use this MMIC application in military field, mainly application is electronic warfare, remote sensing and altimeters, passive mmw imaging and instrumentation and so on, smart monitor, monitoration and decoys, adaptive phased array radar and synthetic aperture radar, and space communication like satellite TV receiver, satellite for communication, radiometers and astronomical fields, synthetic aperture radar and so on. In civil application, mainly satellite TV receiver and wireless communication, fiber optical system, Bluetooth and high-speed internet, and RFD system and medical system and so on. And materials and devices used in MMIC. Which types of materials used for fabricating MMIC? Uh, there are numerous semiconductor compounds materials with wide variety of electronic and optical properties are used in MMIC. Group 3V compounds such as gallium arsenide, indium phosphorus, gallium phosphorus, and aluminum gallium arsenide, and other group 4V 4 elements such as silicon, and other compounds of group uh, 3 4 elements including silicon carbide, silicon G, and all of which are used in MMIC technology. Here is comparison of physical and electrical properties of the MMIC materials. Here mainly compare the physical and electrical properties of silicon, gallium arsenide, germanium, and silicon carbide, and gallium nitride. The electron mobility and resistivity, permittivity, thermal conductivity, wafer size, wafer cost, and energy band gap, and approximate process yield. Mainly the electron mobility of gallium arsenide is mostly here high. We mainly see high value. In case of resistivity, also its value is also high, and the energy band gap here silicon 1.12 and gallium arsenide 1.43, like this. Active devices of MMIC. Several technologies have been developed for MMIC, like gallium arsenide MESFET, gallium arsenide ACMT, gallium nitride ACMT, gallium arsenide HBT, and silicon BGT, and silicon germanium HBT, and silicon CMOS, and indium phosphate ACMT, and indium phosphate HBT, and IMPAT and PIN. Mainly the active device of MMIC material shows application based on application in is dependent on the electron drift saturation, velocity, mobility, and resistivity. Because devices of MMIC, mainly gallium arsenide MESFET. This one show a basic schematic of the gallium arsenide MESFET cross-sectional view, and this one is lumped component equivalent circuit of gallium arsenide MESFET and is equivalent circuit of the MESFET, where the CGS capacitance between the source and the gate, and IDS gain of the devices, RDS resistance of the devices, and CDS resistance RDS resistance of the active channel layer, and CDS capacitance between the drain and the sources. The advantage of gallium arsenide over silicon due to its higher saturated electron drift velocity, lower field mobility, increases the speed of devices, its high resistivity for passive components. The devices of MMIC, gallium arsenide HEMT. This one mainly is cross section of PACMT structure, and here comparison of ACMT and PACMT band gap structure. The basic structure of PACMT, which is a two-dimensional electron gas 2D structure, deliver the higher electron mobility in the 2DEG, and it's exhibit the lowest noise figure with high gain. This is of MMIC gallium arsenide ACMT. Mainly this image a schematic cross section of buffer layer and ACMT devices layer. That means metaphoric devices is this one. Metaphoric device structure have recently been grown on gallium arsenide structure. This structure contain in compositionally graded metaphoric buffer layer to expand the lattice constant. In transforming the lattice constant, crystalline defects are also intentionally formed. These defects are predominantly confined to the metaphoric buffer layer. An application of metaphoric devices technology is growth in indium phosphate based structure on gallium arsenide substrate, because the substrates are available in larger and lower cost than indium phosphate substrate. And device of MMIC gallium nitride ACMT. This image show the uh, axial structure of the basic aluminum gallium nitride or gallium nitride ACMT, and there is the net positive charge at the aluminum gallium nitride and gallium nitride interface. Mainly ACMT are heterojunction interface between the two semiconductor materials, and aluminum gallium nitride is grown on top of the gallium nitride, and aluminum gallium nitride has a higher energy band gap than gallium nitride. The electron gain higher mobility. Ohmic contracts for the source, gate, and drain are introduced by photolithography techniques. The 2DEG is crucial importance for the heterojunction interface. Aluminum gallium nitride and gallium nitride heterostructure is spontaneous due to the piezoelectric polarization effect. Passive devices of MMIC for inductor. MMIC inductor, here you can see the like three types of inductor: ribbon inductor, single loop inductor, multi-turn spiral inductor. This one mainly is micro-step ribbon inductor, where from this equation uh, Z0 that's characteristics impedance, and here L is the inductance and is parasitic C is parasitic capacitance. Passive devices of MMIC like inductor, mainly here loop inductor, and this image show the spiral inductor, this one, and equivalent circuit of the spiral inductor, where L is inductance and Cc means feedback capacitance, and R means resistive losses. Cg1 and Cg2 is parasitic capacitance to the ground. Passive devices of MIC on capacitor. This one the overlay different types of capacitor. This one overlay capacitor, interdigital capacitor, and the MIM capacitor. This image is the equivalent circuit of the capacitor. The MIM capacitor is composed of two metal plates separated by digital materials, dielectric materials. Typically, the dielectric materials overlaps the first materials layer, and upper metal layer has a smaller area than the lower metal layer. The MMIC capacitor, it has high capacitance per unit area, and the capacitor is mainly composed of metal plates separated by dielectric materials. Passive device of MMIC, then one of the is resistor. There are various MMIC register, mainly the Mesa register and the thin film register and gallium arsenide based register. Here R equal to PS L by A and area equal to W multiplication T, where the PS the sheet resistance, W width of resistance, L is length of resistor, and T is the thickness of resistor, and A cross sectional area of the resistor. We can discuss the transmission line. There is two transmission, the microstep and ground coplanar waveguide transmission line. Transmission line mainly consists of a set of conductor and dielectrics material. And we also discuss about combiners and dividers. There are different types of couplers line, the branch line coupler, the ring coupler, the coupler line, and the lens coupler line, and the Williamson coupler line as shown this A to E figure. Isolator and circulator and via hole. The basic configuration of circulator and isolator, as which we see this image, this one the circulator and isolator. What is the isolator? Isolator allows the microwave signal to pass in one direction but not in other direction, which can be achieved by using ferrites. The ferrite material is mounted inside the waveguide and external magnetic field supplied by the C-shaped permanent magnet magnetize the ferrite. And another is, what is the circulator? Circulator routes the microwave signals from one port of the devices to another. If the microwave signal entering at port 1 is directed out of the circulator at port 2, then a signal entering port 3 does not get into port 2 but instead of goes out through port 1. And we can discuss an ideal via hole in the gallium arsenide substrate. Mainly via holes are used in microelectronics to connect different metal layers in an IC circuit, but also can use to electrically connected both sides of silicon wafer. So this so called the through wafer holes or via holes, and can be used in broad range of applications such as a two-dimensional packaging, three-dimensional packaging, micro electrochemical system MEMS, or multi-chip stacking. Both microstep and backside grounded coplanar waveguide technology requires via holes either to provide microstep short circuits or to tie the upper and lower grounded planes of the coplanar waveguide together. Last of all, we discuss also wire bonding and bond pads. Here we discuss about wire bonding and flip chip. Mainly interconnection. In case of IC, interconnection is necessary between the MMIC and is accomplished by the wire bonding. Bond pads are provided also to allow wire bonding for electrical connection. Through the wire bonding and bond pads, DC bias can be supplied and output signals can be taken out. However, in this process of the wire bonding, serious consequences can arise due to the low pass characteristics as shown figure. This figure, wire bonding figure. The use of interconnection in MMIC is required for accurate modeling to avoid unwanted resonances. However, there is an alternative technology called flip chip method, and this one shown in this figure. in which shoulder bumps are used rather than wire bonding. These bumps avoid to low pass characteristics of the wire bonding connection. The series inductor and shunt capacitor can be reduced by the using flip chip technology. Flip chip technology. And thank you to all. Now finish my review of MMI technology shortly.